Can I get your name and profession, please?
My name is Fred Jordan, and I'm a professor at Curtin University, and I'm director of the Argon Lab where we date rocks.
Excellent. Therefore, you would know a little bit about the Devil's Marbles. So, can you please tell me what they are? What are the Devil's Marbles?
So the Devil's Marble, simply put, they are just block of granite stand in the middle of nowhere. So picture that. You come with your car, there's grass and bush everywhere, and right in front of you, you got a big round block of granite on top of each other, looking orangish, and you don't even know why they are standing there. There's nothing around.
So, do you know, has there been research done into why they are there and how they got there?
This is a very classic phenomenon of granite erosion. Do you want the full story?
Yeah.
Yes, all right. So they started their life as magma deep into the mantle. So you had a plate that subducted below another plate and put water in the mantle melt, and the magma rise. Some of the magma erupt at the surface as volcanoes. Some of the magma just become too mushy and is trapped underground. They are like magma chamber, if you want, but they don't erupt. They just stay underground and they solidify and form crystal, and they become what is known as a granite. Now that happened 1.7 billion years ago. It's a very long time. So it stayed deep underground for that long. But progressively, natural vacuum cleaner remove all the layer on top of it, slowly over 1.7 billion years, and at some stage the granite arrive at the surface. Okay? When it does that, the thing is, it was very pressured when it in place deep underground, right? A lot of pressure. It's like you take a fish from the bottom of the ocean and you put it at the surface. It's going to decompress, not going to be good. That's the same for the granite. They decompress. So they start to crack, all right? And they crack vertically, horizontally. So you get joint like that, so you get square blocks on top of each other. That's what happened. Cracks means the water can flow into it, so it will. So what happened is like it's going to transform part of the rock. It's a phenomenon we call weathering. And part of this rock is going to turn into clay. Now, natural vacuum cleaner, erosion, remove this clay progressively, and you're left with square block on top of each other. But wait a minute, they are not square block, they are round. So what happened? Another layer of weathering on top of it. So two types. The one we just encountered before, with the liquid flow, the water that's slowly erodes things away by dissolving them. And another one is, I want to say personally more fascinating, is thermal stress, right? It's a bit like when you take a plate out of the oven and you put it straight under cold water. What's going to happen? It cracks, okay? And I have a friend that made the experience and he cut his finger out of it, so don't do that at home. It's not good. So this granite is the same, it's no exception. So where is the heat coming from? The sun, during daylight. Scorching temperature in Australian desert. And then the night is cold. Warm, cold, warm, cold. Mechanical stress. It's a bit like you take, those metal pins and you keep moving them and eventually they crack. So the granite, it's exactly the same that happened to it, except it doesn't crack like a pin in a particular location. It cracks as a layer like an onion. So it peels this layer. So if you have edge around, they are the first one to go. Nature doesn't like edge. And if you want to convince yourself it's true, you just go simply in a riverbed and you look at the rocks. They're all rounded pebble, right? All the edge have been removed. That's the same on a bigger scale. So you get your round block that is now that lay on top of each other, but there's something fascinating about those rocks. Some of them, they're just round block on top of round block, right? How come they don't fall? And that is truly fascinating over there. It's not that easy to explain, but I'm gonna try anyway. So you get your square block on top of each other, and nature that round them progressively, right? So it removes material until it stands on top of each other like that. And this part is still flat. So it's not too hard. And you see generation of people that come and try to push this granite. The mass is enormous. You can't just remove them like that. Yep.
Excellent. That was a great answer. There was so much in there.
Yeah,
Thank you
feed
so
me
much.
question to just repump a bit of
Yeah.
of idea into
No,
me.
you did an excellent job. So I mean, anything else I ask you is going to be essentially a
Yeah.
paraphrase of
Yep,
everything
no
you just
problem.
said. I'm sorry.
No, cool.
So
Just couldn't stop myself.
yeah,
Just- I
and that
just
was
wanted
really
to-
good. There's really good grabs in there. Will the devil's marbles ever move or fall?
Obviously, erosion. Well, let me rephrase that. Obviously, the devil's marble, they won't be there forever. At least the one we see now, right? They're going to be replaced. So the block, they're going to move, they're going to fall. Erosion is going to dissolve them away. It's going to form soil and clay. But erosion keeps going. So unearth new blocks. That's going to get rounded and new devil's marbles if you want. So the volume of granite below is so enormous that's going to continue for hundreds of millions of years, if not billion.
Excellent. Again, you've already said this, but anyway, how did the devil's marbles end up balancing on top of each other?
So one thing which is very interesting with those marble is that they precariously, is that right? So one thing which is very interesting with those devil's marble is that they precariously stand on top of each other, like it's almost impossible. You know, you can't, you don't understand how it's happening. In fact, it's not too hard to explain. Now, like I said, you had a network of fracture making square block, and nature trying to round those blocks. So two square block on top of each other, people, they are not surprised of that. It's just happen all the time. The surprising fact is they are rounded. So they are square block, top of each other, getting progressively rounded and balanced on one single flat point. And that's how they stand, because they were already in equilibrium before, right? No.
Yeah, that was.
No, that was. Oh, that's because of this.
Yeah.
Okay.
Yeah. No, the answer was great. It's just.
No, if it's not, please ask me. I'll redo it. I have no problem.
Oh no. You're doing great. It was just listening to that.
No, sometimes I do that in real class. I mean, I'm just, let me restart. It was terrible.
Sorry, students, let me restart that.
Yeah, I really
Like
do
you
that. I
guys,
really do
yeah.
that. It's like, forget that. I'm going to redo it.
Are there any other rock formations around the world that balance similarly to the devil's marbles?
So the devil's marbles, they are kind of unique because of their color and the setting. You know, in middle of bushy area like that, orange, a bit like Uluru, right? That's poetic to me. That's very nice. But the round granite erosion type is fairly common indeed. Everywhere you can find that. We got other part of Australia where we have round granite. I think what's so striking with the devil's marble is that it's completely flat around, right? Usually you get a bit of relief here and there. Here it's flat. You just have that in the middle.
Is there any particular reason that it would have been like that? Is it just the luck of the draw that it's flat and then they're there?
So, can I answer your question about the impossible? Because that goes right in there.
Yeah.
So for me, this formation is almost impossible because it's hard to comprehend that just a little bit has been spared, right? You would imagine the nature, they just polish everywhere the same. So you end up in many parts of the world with big round granite like in Yosemite Park, you know, round mountain and things. But this one is flat, except this little bit that just protrude out of the ground. And to me, it's impossible. It's really hard to explain why it's like that.
Always such a winner. Okay, is there anything that you know of that's still unknown about this area? Any kind of new discoveries that are being done or studies or anything? If not, then that's fine. It's just a question that we're asking.
No. I don't want to answer that. I would go in unknown territory.
Yeah, that's fine. It'd be good to get a line from you as to their location.
Oh, yay!
Yeah, that's okay. So where can we find the Devil's Marbles, please?
So the Devil's Marble, they are typically in the middle of Australia, right? But in the middle of nowhere in Australia. They are close to, well, close by Australian standard, close to Alice Spring, a little city in the middle of Australia. They are Northern Territory, and they are not too far from Uluru. So, which is interesting, if you do a trip to visit there, you can combine the two of them. They're really great sight to see.
Thank you so much. Is it just, and this is kind of, I'm kind of diverting, I'm sorry, but do you know the type of rock that they're made of? Is it common for these kind of balancing formations to exist?
Yeah, so depending the type of rock, you have different type of weathering and alteration. Take, for example, the Chinese rock forest, right? So it becomes full of holes. Rocks is a karstic formation. So you get cave, you get holes, and you get this single thing typical of limestone. Granite, totally different beast, likes to erode roundly. And that comes to technical detail about the property of the rock, how hard it is. Limestone, the Chinese forest, is very soft. Granite is harder. Now you get another type of volcanic rock like basalt, which is way harder and erode completely differently.
Excellent, thank you so much. Do you know anything about the age of the rocks? I know you've kind of already said it.
Yeah, I can say it again.
One of the questions, how long have the Devil's Marbles been here?
Yeah, no, that I can't tell you. Let me tell you something, you'll see what you make out of it.
Yeah.
So the rock itself that constitutes the Devil's Marble, the granite, has been formed 1.7 billion years ago, has been in Australia forever. Now, it stayed on the ground for a very long period of time because it takes a lot of time to erode layers above it, especially with the kind of climate we have. You know, in Australia, for geologists, we always say nothing happened because erosion is so slow. You don't have big chain of mountain, for example, right? So it took forever to take this granite to the surface. When did it start to be out? I personally don't know. If I take a guess, I would say few tens of millions of years. But the boulder themselves, they erode fairly quickly once they are above. But new ones form. So you always will have those Devil's Marble for a very long time, hundreds of millions of years. But they're going to always be new one, a bit like the cell in your body that constantly renew, right? It's the same thing.
Wonderful, thank you so much. I reckon the other stuff is things like local legends and and then their naming. So unless you knew anything about that,
I just read it on the net, to be honest, because that's nothing to do with geology.
That's exactly right. And
yeah.
We've got like a tour guide who can talk about it. But if you wanted to talk about it, then we're always happy to hear from you, friend.
No, I just know what I read. You know,
okay.
I can tell you. You know, it's just like they assume it's like the eggs of a giant snake, but that's all I know about it.
Yeah.
Yeah.
Okay.
So.
In that case,
Tourist guide much better.
Yeah.
Is Phil.
That's kind of like all the questions. You've covered everything. You've explained the chemical process that influenced the rock formation to occur. I mean, yeah, everything else is going to be, you know, what makes them so special to you. You've not been there, so that's fine.
Oh, but I want to answer that.
Okay.
I still can, because I can relate. Like I see, I've seen this kind of formation before.
Okay.
So I've not been to this one, but exactly almost a twin, if you want, right?
Oh, okay.
In Africa. In Africa, it's the same kind of settings, if you want. You remember what I said? Like depending where they are are altered in different way. They have different colors. But in Africa, it's like a bit sister of Australia in many ways, and like, you know, baobab. So those rock, to me, they call the inner child in me, because the first thing I want to do is not to take my hammer and sample them, and I can't because it's on sacred ground for Aborigines, so you can't sample them. But still, the first thing I want to do, like every kids that goes there, is to climb on them and just walk and climb a little bit here and there and explore around. It looks like it's from a different world. So yeah, the little child explorer in me wanna visit those.
And tell me about the kind of the African version of them.
Yeah, so if I recall correctly, that was in South Africa. They have big pocket of granite as well, much younger though, around 180 million years. And those granite, they erode the same way. The climate is fairly similar, so you expect to find the same thing at the surface. And yeah, round boulder on top of each other, and a real playground for kids, that's for sure.
Excellent. Yeah, it is quite impressive that nature does this. And you're good at this. You've done it already, but I'm gonna ask you to do it again. If you could explain to someone who had never seen the Devil's Marbles before, can you explain to me what they look like, please?
So you take your car, you arrive in the middle of absolutely nowhere, right? And there's grassy bush and things, and it's fairly, burnt grass, actually, very yellow. And then in the middle of nowhere, you get a rounded block. They look orangish, perhaps because there's a bit of iron in it that get rusted, I think. And more striking, some of those blocks, they precariously stand on top of each other, and seemingly they're gonna fall every minute now, but just they don't. They just stand like that. So you get this fascinating agglomeration of rock and the precariously things that balance on each other, all together in a flat landscape that makes it for a very magical visit indeed.
Thank you so much, Fred. Is there anything else that you think would be important to mention about the geology or anything like that, the creation of the area that I haven't asked you to cover?
No, I think I did that when I gave the complete story. So I know you're gonna take just part of it and stuff. That's fine.
Yeah.
But I think I've been comprehensive on this one. I tried to be.
Yeah.
Okay. Yeah.
Awesome.
If you miss anything, just ask me to come back, and I'll do even for a line. It's okay. But if I do that, just make sure it's already set up because it's in and out.
Yeah, that's exactly right.
Yeah.